Hi, this is Mrs. MacPhee, and I wanted to talk to you a little bit today about a strategy for dividing fractions that I am totally in love with. I think it's going to make things so much easier for you if you use this strategy at times. A lot of times when we have students come to class, they're very good at understanding the procedure for dividing fractions. They will say, I'm going to keep, change, or I'm going to keep, multiply, flip. Or some students who are really brilliant will say, I'm going to keep the first fraction and then I'm going to multiply by the reciprocal. And they even understand that reciprocal would be 26/5. And they're totally right. 7/13, and then we'd multiply by 26/5. But this problem is still rather difficult. And the bigger question is, well, why do we do that? And most students will tell us, well, because my teacher told me. And again, our elementary school teachers do a great job. Students come to school, they understand this strategy, but they don't really understand why. If we revisit the initial problem and we think about when we add and subtract fractions, our first step is to always get a common denominator. We can actually use that same exact strategy when we divide fractions. So instead of learning a new procedure, we can keep the same procedure we use for adding and subtracting. So if we look at 13 and 26, 13 is actually a factor of 26. So we could change our 7/13 by multiplying both values by 2 to get an equivalent fraction, 14/26. And now we can substitute 14/26 into the original problem. So now our expression would be 14/26 divided by 5/26. And at this point, I generally haven't convinced anybody this strategy is any easier. It looks like a more complicated problem. Now the denominators are both 26, and that's the exact same point. Because the denominators are both 26, we can start dividing. When we divide 26 divided by 26, what do we come up with? Well, we come up with 1. Any number divided by itself is 1. Well, what do we have left? We have 14 divided by 5. So what we have here, if we remember that a fraction is also a division problem, we have 14/5 divided by 1, which gives us 14/5, which means if I change my original expression to an expression that has a common denominator, my denominator will then become 1, and I'm left with my answer, 14/5. If you wanted to double check and use the procedure we've seen in the past, we could have our 7/13 times 26/5, and some students might see that we could cross cancel. 13 divided by 13 is 1. And 26 divided by 13 is 2, and we still get 7 times 2, 14, over 1 times 5, 5. Equally great strategy. The one word of caution that I've seen is sometimes students don't see they can cancel out. Some students start multiplying and they say 7 times 26, and then they start doing the math, and they're very good with their math, and they get 7 times 6, it's 42, and I carry the 4, and 7 times 2 is 14, plus the 4 that I carried is 18, over 13 times 5, which is 65, and they get to this point and they're done. They do not want to do any more work, and they don't actually see that this number can continue to be simplified, because at this point, who would recognize that you can actually simplify this number by 13? And when you do, guess what? You get 14/5. Original problem, looking to get a common denominator, change any fractions you had into equivalent fractions. Your denominator cancels out, and we're left with 14 divided by 5, which is 14/5. Thank you.